Welcome to Psych 200, okay, research methods. Today we're talking about still experimental designs, so more about experimental designs. You're going to learn the difference between what's called a between subjects experimental design and a within subjects experimental design. So there's different kinds of experiments. There's between subjects and within subjects. Okay, there is no separate chapter for this on your textbook, but I'm covering it as a separate lecture. Okay, so why don't we get started? It's going to be a bit redundant. We already mentioned a lot of these things that are on here, so perhaps I can shorten this to, so it only takes up one lecture rather than two. But well, it's the way I first designed it, so it's still that way. So, introduction to between subjects experiments. So first, let's review experimental research. Okay, remember, with experimental research, the goal is to demonstrate a cause and effect relationship between variables. You want to say that A causes B, alcohol causes aggression, or exercise causes a reduction in weight, or whatever it is. So remember, experiments have certain requirements. You have to manipulate at least one variable, okay? The one that you're hoping will be basically the cause. You're going to manipulate that one. You're going to vary exercise, you can vary alcohol, something like that. That's usually your independent variable, right? And you're going to measure a second variable. That's your dependent variable. And then you compare the scores between treatments. You compare those, for instance, that received alcohol with those that did not, or those that, for instance, did some exercise with those that did not, right? And you try to control all other variables, all other things that can have an impact on the outcome. You try to control those things so that they are not a factor. So let's talk about the difference between within subjects designs and between subjects designs. So in within subjects designs, which are the second ones we're going to talk about, not today, we'll get to them eventually, to these types of experiments. Within subjects designs, you have different sets of scores that are obtained from the same group of participants. Okay, so in within subjects designs, basically your experimental group and your control group are made up of the same participants, and I'll talk more about those later. With between subjects designs, each set of scores is obtained from a different group of participants. So those in the experimental group or the treatment group, those are different participants than those in the control group. And by the way, when we usually think of experiments, it is that version that we usually think about. We're usually thinking about between subjects designs, okay? We usually think, right, that those in the control group are different people than those in the treatment group. That's a between subjects design. But there's this other one that's a little bit different called the within subjects design, that uses the same participants for all groups that are being compared. And we're going to eventually talk about advantages and disadvantages of each. They each have their strengths and weaknesses. Characteristics of between subjects design. So it's experimental research where you manipulate an independent variable, okay? And then you measure a dependent variable for each experiment. So just like what we said before, same thing is happening here, okay? The goal is to determine whether there's a difference between two or more treatment conditions. Is there a difference between the experimental group and the control group, okay? Or the experimental group and a placebo group, and maybe even a control group. There could be multiple groups that you compare. There's a requirement, right? The requirement is that there's only one score for each participant. Okay, only one score for each participant is obtained. In other words, what that means is that participants is either in the control group or in the experimental group, not both. Okay, you don't get a score for them in the control group and in the treatment group. They're only in one group. That's what that means. It's not really accurate to call it one score because you can have many things that you're measuring, but it means they're either in one group or another. They can't be in both. Okay. So separate groups of participants are used for different treatment conditions. And here's a visual to help you understand this. Okay, and this makes it very clear. So you have a sample. So the circle there at the top, right? That's a sample of participants. Okay, that's obtained from the population. So let's say you have a population of people from which you obtained a group of people that are going to be in your experiment. That's your sample. And then that sample is broken up into three separate groups. Group 1, Group 2, Group 3. There's different participants in each group. And you're going to obtain scores for each group. okay? And then you can compare those groups. That's a between subjects experiment or between subjects design. This is usually what we think of when we talk about experiments. Now, it's different for a within subjects design. For a within subjects design, you have a sample of participants. You know, you have the circle there on the left, right? And then those participants are going to be in the treatment condition. Okay. And then they go on and they're going to be in another treatment condition 2 and 3. Okay. So with within subject design, they get to participate in basically all groups. This one perhaps isn't too clear, but to give you the simplest version of this, in a within subjects design, the participants would basically be in the control group, and they would also participate in the treatment group. Same people, okay? And you're going to compare the different groups, but they're made up of the same people. So here we have treatment condition 1, treatment condition 2, treatment condition 3. Okay, that is possible. Okay, you could have, you know, the treatment condition 1 could be the experimental group, treatment condition 2 can be the placebo group, and treatment condition 3 could be a control group. Okay, so treatment condition 1, basically they get alcohol, the participants get alcohol, for instance, and then you test their level of aggression and you see what the average is for the group. And then maybe, you know, maybe days later or a week later, they get to participate in treatment condition 2. Now they get the same participants will now get the placebo, and then you test their level of aggression. And then maybe sometime later, you know, they get to be in the control group. Okay, so they're not going to get any alcohol, let's say, and you test their level of aggression. The same participants in each group. I know that might sound odd to some of you because you're used to thinking of experiments in the other way, but it is a valid way to do an experiment. Okay, but we'll talk about those a bit later. But right now I'm just describing the difference. Advantages of between subjects designs. Okay, so what's the advantage of having separate participants in the control group, in the treatment group, in the placebo group? What's the advantage of that? Well, one advantage is that each individual score is independent from the other scores. So each individual score is independent because it is from different people. Okay. The individual score is also not influenced by practice or experience gained in other treatments. So imagine if you have a participant that gets to be in the treatment group, right? And then they get to be in the control group. They get to be in the placebo group. They get to go through the experiment multiple times. And because of that, the way they behave can be affected. They're getting practice, so to speak. They're gaining experience. They're learning more about the experiment. And you don't necessarily want them to know what you're doing, okay? So that's called a practice effect, okay, or experience effect. That doesn't happen in between subjects design. They participate once and that's it. There's no issue with fatigue or boredom from participating in a series of different treatments. So you can imagine if you have a within subject design, they get to participate in the treatment group and the control group and the placebo group. They get to go through the experiment 3 times. That can be annoying, okay? They can get tired, they can get fatigued. And because of that, they may not pay as much of attention or take it as seriously, right? That's a problem. You can also have contrast effect resulting from comparing one treatment group to another. So if you get to be, let's say, in the treatment group, right, the alcohol group, and you get to have real alcohol and you get really drunk, right? And then, you know, at some other time, you get to be in the control group where you get no alcohol, right? It will seem very different. That's called a contrast effect. And that can basically affect results. Think of it this way. This is an example of the contrast effect. If you put your hand in a bucket of very cold water, okay? If you do that, and then right after that, you put your hand in a bucket of water at room temperature, lukewarm water, right? First you put your hand in a bucket of very cold water, and then you put it in a bucket of water at room temperature. Well, when you stick your hand in that bucket of water at room temperature, it is going to seem hot in comparison. Because you just experienced something really cold, and now you're experiencing something that's not so cold, and it's going to seem hot in comparison, even though it's not hot. Just like when you take a shower, let's say it's a really cold day, and you just came from outside, and your body is really cold. So you turn on the shower, and because it's cold, you're going to, you're going to use warm water. So you turn on the warm water, And at first you feel like you're burning because your body is so cold, right, from being outside, and now it's getting exposed to warm water, but it feels hot in comparison. That's the contrast effect. Similar things can happen when you have people participating, let's say, in the treatment group versus the no treatment group versus the placebo group. It can seem very different just because of that contrast effect. Okay, especially if they get to participate in one group versus and then another relatively quickly. Let's keep going. There are also disadvantages of between subject design. There are some things that are not so good. So it requires a relatively large number of participants to do a between subjects design, because each group, each treatment condition is made up of different people. So if there's 3 treatment conditions and you want to have 30 participants per treatment condition, that means you're going to need 90 participants, because you have 3 different groups, 30 in each will give you 90. And within subject design, you wouldn't need 90, you would just need 30, because the same 30 would be in each group. So that's a big disadvantage. You need more participants. And when you're doing experiments, it's actually hard to get a large number of participants, because experiments take a long time. They're tedious. It's just, they're more complicated. It's not like a survey where you can get hundreds of participants really fast. In an experiment, just to get one participant to participate, just to run one participant through the experiment, takes quite a bit of time. It can take a half hour, an hour, a couple of hours, depending on the experiment, just for one person. You can imagine, right? If you need a lot of participants, how long it's going to take. Another disadvantage is that each score is obtained from a unique individual who has personal characteristics different from all other participants. So another disadvantage is basically that each participant is different than the others. Okay, people are going to be different. They're going to differ, in age, in personality. They can differ in sex, and they can differ in sexual orientation, in IQ, all kinds of things. So that's going to produce high variability in your scores. So there's going to be a lot of variation in the scores that you get. And variation is both good and bad. And I'll describe that later. But in this case, we're only talking about the bad form of variation. If there's a lot of variability, it's going to be harder for you to find a significant result. But I'll explain that a bit later when we talk about that. Okay, because there's good variation and then there's bad variation in the scores. It depends on what level it's at. We'll talk about that. So these individual differences, the fact that your participants differ, okay, can basically create what are called confounding variables that we talked about before. One of those confounding variables, well, for instance, because you have different participants, your experiment can suffer from what's called assignment bias, okay? That applies exclusively to research designs that are between subjects. So when you have a between subjects experiments, you can have assignment bias. So you're going to have different participants in your different groups. And if you don't assign participants to the groups in the correct way, you can end up with a group of participants that's relatively older than the other groups, or maybe has a higher IQ, or has more males or more females, or there can be differences among the groups that are not due to the treatment. That's assignment bias, okay? And that can create a confounding variable. A confounding variable is any extraneous variable that's systematically differentiating the group. So if you have a group that's relatively older, for instance, okay, one of your groups is older than the other groups on average, that's going to affect, for instance, the level of aggression that you see in your experiments. Because guess what? Young people are usually more aggressive. It's young people who cause most of the problems, that we see. It's young people usually who are incarcerated more often. People in their teens, late teens, early 20s, even 30s, but it's the younger people are more of a problem. Once you get to about your 40s, it's not that big of a problem anymore. It's like people get tired and then they're not out there doing all that stupid stuff they do that gets them into trouble, okay? They kind of mellow out after 40. So you have more younger people, more people in their late teens, and especially in their 20s, who are incarcerated. Okay, so think about if we're just doing an experiment that's to do with aggression, right? And you have one group of people who happens to be relatively older. That's probably going to be your least aggressive group. Or you have a group of participants with more males, right? Let's say your experimental group, your treatment group has more males than your control group. That's a problem. You have a confounding variable. Males are naturally more aggressive than females. So when you don't assign participants evenly, when you don't assign them correctly, randomly, whatever you want to call it, right? You can have a confounding variable, okay? Groups with different characteristics, like having one older, than another, or, more males in one group than another, so groups with different characteristics, right, will threaten the internal validity of the study. Internal validity, remember, is about cause and effect, okay? So if you have a group of participants that's relatively older, right, or that has more males or whatever it is, then you can't be certain that it's actually your independent variable, like the alcohol, that's causing the aggression, and not the difference in males and females in your study, or not the fact that one of your groups is older than the other. And when an experiment is confounded, it is impossible to draw any clear conclusions. You don't know what's really causing what. Okay, that's the problem with assignment bias. Now, there are ways to deal with this, okay? So here's an example with age as a confounding variable. And I mentioned this already. Treatment 1, you have a group of relatively younger participants. Guess what? They will probably be the more aggressive group if you're talking about, alcohol consumption. If you're talking about the effect of alcohol on aggression, if that's what you're testing, and one of your groups is relatively younger, right? They're in their late teens, early 20s, right? They will probably be more aggressive. And then you have a group of relatively younger. Wait, okay, I got it reversed. So treatment 1 is a group of relatively older participants, okay? They will be the ones that will be least aggressive. And then you have a group of relatively younger participants, right? Those are the ones who will be more aggressive. And I explained why already. Naturally, younger people, and I'm not talking about kids here, but I'm talking about people who are already adults, okay? Late teens, early 20s, they're naturally more aggressive. They have higher levels of testosterone. They're more capable of inflicting harm. They are basically not as, they're not as wise, they're not as able to control their behavior as, say, people who are older and more experienced, okay? So, that's going to affect your results, okay? So if the scores in one group are different from the scores in another group, the difference may be caused by the treatments, that's what you want, or it may be caused by the age difference. So you have a compound, potential compound, which is age. Additional confounding variables, okay? There's actually two major sources of confounding variables in between subjects designs. You have confounding from individual differences that we just talked about. That's called assignment bias. As examples, participants in one group may be older, they may be smarter, taller, they can have a higher socioeconomic status. That means that they're relatively richer, let's say, than another group, right? Or one group's relatively poor, right? Than participants in another group. But you can also have confounding from environmental variables. Confounding with things that are external factors. For example, you can have, you can test, let's say, one group in a large room and another group in a small room. If you're testing the effect of alcohol on aggressive behavior, maybe being in a smaller room is more annoying, more frustrating, and that will affect the level of aggression. So confounds can come from different sources, and we talked plenty about confounds already. It's just now we're just talking about it as a basically as a flaw, a weakness, a shortcoming of between subjects designs. So there's a lot of redundancy in this lecture, okay? But we're going to differentiate between subject design and within subject design. So we have to talk about this, okay? Equivalent groups. So the researcher has control over creating groups that are equivalent. You want groups that are equivalent, okay? You want your control group, your treatment group, your placebo group. If you have all those groups, you want them to be equivalent. Equivalent in the sense of, the participants, okay? The groups must be created equally. They must be treated equally and composed of equivalent individuals. That last one is important. You have to have participants that are relatively the same age, relatively the same percentage of males and females in each. Even ethnicity, you want that to be relatively equal from the different groups. You don't want, for instance, one group, let's say, to have more Asians than another group. Research shows that Asians are actually less aggressive. Asian people do not express their aggression that readily, not publicly. That's what the research suggests. They do get upset, but they won't show it. And when you're running an experiment and you have a bunch of Asian people in one group and you have less in another group, guess what? Your group with more Asian people is going to have a lower level of aggression. That doesn't mean that they didn't get upset. Okay, it's just that, you know, their culture emphasizes not basically showing anger or aggression publicly. Okay, so you need equivalent individuals. You need the same number. You know, you need ethnicity assigned equivalently across groups, right? Gender, right? Sex, whatever you want to call it, age, all those things. You want equivalent groups so that you don't have this assignment bias. So you don't have these potential confounds. Let's keep going. There are ways to limit these individual differences, a way to basically potentially get rid of these confounds. And we actually talked about them already. So I'm just going to mention them now. Okay. Primary techniques, random assignment. If you assign participants randomly to groups, you know, through say a coin toss, we don't do a coin toss, or rolling the dice, that's random, but we don't do that. It's done by computer. But if you use random assignment, and if you have a large number of participants, chances are they're going to end up evenly divided among the different groups. Just like when you flip a coin, maybe 100 times, you're going to get pretty close to 50-50. You're going to get pretty close to having 50 heads, 50 tails. Okay, maybe not exactly that, but pretty close. Maybe it'll be 48-52 or something like that, or something close. Okay. Another way to make sure you can get rid of this assignment bias, that can lead to potential confounds, is to use matching. We talked about that, right? Match individuals in the group on a specific variable. Make sure their average age is about the same. Make sure that you have the same number of males and females in each group. Make sure that you have, ethnicity matched across the different groups, right? That's important, so that you can't really say, well, the result is due to the fact that one group is older. No, one group is not older. They have about the same average age. You can also hold variables constant. We talked about that already. An example would be a researcher suspecting the variable gender might be a confounding variable, would eliminate gender as a variable. You can eliminate gender and, let's say, run your experiment with only females or only males. That's holding constant. Okay. We talked about this already. Okay, but that's ways. There are ways to limit the drawbacks, the weaknesses of between subjects experimental designs. Now, I mentioned variability before. Variability can be both good and bad. Okay, so the effects of variability in between subjects designs. So, as I said before, because your different groups are made up of different participants, you're going to have more variability in the scores that you obtain. There's going to be more variability. Okay, large differences between individuals produce large variance. Okay, so because people differ in all sorts of ways, that means their scores can be very different, and that produces a large variance. Okay, variance, just think of variance as variation. Okay, think of it that way. Okay. Even though it's a statistical term and there's a way to compute the variance, it's due to variation. Okay, the more variation in the scores, the larger your standard deviation, right? The larger your variance. Okay, so large differences between individuals produces a large variance, produces a lot of variation. Okay, increasing or decreasing variance. Okay, you can increase it, you can decrease it in certain ways, right? Increasing or decreasing the variance may have a significant influence on the statistical interpretation of the results. So increasing or decreasing the variation in the scores can affect whether you find a real difference in the scores, let's say between the treatment and the control group. It affects the statistical interpretation. And I'll explain how in a moment. Significant means, remember, the significant means that it is very unlikely that the difference would occur if there was not a consistent difference between treatment conditions. Significant means that your difference is real. Okay, that it's due to having different groups, different treatments, okay? And it's not due to chance, it's not due to some confounding variable. That's what significant means. There's a real difference. Let's keep going. Let's talk about this variation. here we have two simulated populations. So we have two groups here, or two populations. You have population A and population B. And you can see that in population A, if you look at the numbers there and look at the numbers carefully, you'll see that there's very little variation there among those scores. Look, all the scores vary between, it looks like between 38 and 42. So all the scores are within that 4-point range, if I'm looking at it correctly. I know that 38 is the lowest I see and 42 seems to be the highest I see. I don't know if there's anything lower than that, anything higher than that. Now, population B is a population with more variation in the scores. It's a lot more variation. The lowest score I can see, I see a 20. I don't know if there's anything lower than that. And the highest score I see, well, I see a 60. I don't know if there's something higher than that, but there's a lot more variation. From 20 to 60 is a difference of 40 points. And in population A, it's a difference of 4 points. So population B has like 10 times more variation in the scores. Guess which one of these it's harder to find significance in when you're doing an experiment, okay? It actually depends on if the variation is between your groups or within your groups. And I'll explain what that means in a moment. So an experiment in which individual differences are relatively small. Okay, so here we have results from a simulated experiment containing two conditions, right? Using participants selected from a population in which the individual differences are small. Okay, so if you have a population where the individual differences are small, okay, and that's where you select your participants, then when you do an experiment, assuming the experiment works, it's going to be very easy to see the differences. The differences, let's say, among the different groups. So you have the control group. That's what you have in blue on the left there on the graph. So you can see their scores. They all vary from like 38 to 42. And then you have your participants who were in the treatment group. Their scores are in white. Okay, and you can see that their scores also vary by about 5 points, it looks like. Okay, now because the scores don't vary very much within the groups, you can see the difference between the control group and the treatment group very easily. So variation can be a good thing and it can be a bad thing. I'm probably getting ahead of myself, but when there's little variation, when there's very little variation within the groups, it's easier to see differences between the groups. So if you can, let's say, control the variation, let's say within your alcohol group, you can make it so the scores don't vary very much. They're all relatively aggressive. And then you can control the variation in your control group. The control group that didn't get any alcohol, they're all relatively non-aggressive. Then you can see the significance, right? The difference very easily. Okay. So variation can be a good thing. I mean, a lack of variation, right, can be a good thing, but it can also be bad. Okay. So here's what I'm trying to explain. Okay. Differences between treatments and variance within treatments. So here's the thing. Large differences between treatments are actually good. Okay. If you have a lot of variation between, let's say, your treatment group and your control group, that's actually good. That allows you to see the difference very easily. It allows you to find significance very easily. So here, if I go back to the image here, you can see there's a large variation between those in the control group and the treatment condition. You can see the large variation there. There's no overlap. So that's good. That allows you to more easily find significance. But large differences within treatments are actually bad. If there's a lot of variation in your control group and a lot of variation in your alcohol group, let's say, that's actually a bad thing. That makes it harder to find a difference, harder to find a significant difference. Differences that exist inside the treatment conditions determine the variance of the score. So large variance can hide patterns in the data. Now you can't really see it here because this is the opposite, but if there was a lot of variation in the control group and a lot of variation in my treatment group, then the scores would be all over the place and you would see these two groups overlap a lot and you wouldn't be able to see the difference very well. And I'll show you an example a visual example of that in a moment. The point about this is that if you're talking about variation in scores, right? If the variation is between treatments, right? If there's a lot of variation among the different groups, that is a good thing, because that means that the alcohol group, let's say, and the no alcohol group are very different. Okay, so there's significance there. But if there's large variation within the groups, that's a bad thing. That makes it harder to find significance. So there's a lot of variation in the scores among those that consumed alcohol, and there's a lot of variation in the scores among those that didn't consume alcohol. That's bad. Too much variation within the groups makes it harder to see the difference. So researchers try to increase the differences between treatments. So we want large variation between the groups, but we want very little variation within treatments. We try to decrease the variance or decrease the difference within the treatments. And here's an example where there are large differences within the groups. So your control group there, it's in blue, right? Your control group is in blue. And you can see that there's a lot of variation in the scores. If you look at the data on the left, right, the control group scores vary from like 20 to 60, it looks like. And then there's also a lot of variation in the treatment condition. Scores vary from about, let's say, what's the lowest one I can find? Maybe 30 to 66, right? There's a lot of variation there too. So if we were to graph that, you can see, right, in blue, we have the control group. You can see how scattered, right, the scores are there. There's a lot of variation. And you can see in the treatment group, which is in white, you can see that the scores are really scattered too. And you graph them, you can see there's a lot of overlap. Can you really see the difference there between the control condition and the treatment condition? You really can't see it. It's hard, okay? And guess what? When you run your tests of significance, right? When you do your statistics, you're probably going to find that it's a non-significant difference. Because the test is going to say that there's really no significant difference there. There's too much overlap. So there probably is a difference, but the difference is too small for you to actually see it clearly. And the numbers are not really going to work out. You can see that there's a big difference between this. There's a lot of variation within groups. And here, there's very little variation within groups. You can clearly see the difference here when there's very little variation within the groups. And it's hard to see the difference here when there's a lot of variation, within the groups. That's the lesson there. Okay, let's keep going. So we want to minimize variance within treatment. So within the groups, we don't want there to be a lot of difference, okay? And there's a way to do that. How do we make it so there's not a lot of difference within the treatments? Well, we can standardize the procedure and the treatment settings, right? We need to standardize the experiment. Make sure it's the same for everyone. Have a very controlled experiment with very clear instructions, very clear procedures. It can't be messy, right? It needs to be very well standardized, okay? Very standardized. So it always runs the same way. Kind of like an assembly line. When they're building a car, if it's standardized, then all your cars are going to look the same. So if they're building a Toyota Corolla, they're all going to look the same. They're all going to have the same stuff, okay? You standardize it. Now, if it wasn't standardized, then when you build these cars in these assembly line, some Corollas will look different than the others. Some of them will have defects. Some of them won't. And that's not a good thing. You want it to be standardized so they all basically turn out the same. You want to do the same thing with your experiment, okay? Those in the experimental group, they have slightly different instructions than those in the control group. And you want it to be very, very, you want it to be very similar. The experiment, you want it to be practically the same. Everyone in your experimental group is going to go through exactly the same thing. Everyone in your control group is going to go through exactly the same thing. So you want to standardize it so that minimizes the differences that you can find. Okay. You also want to limit individual differences. You want to limit the differences, of the participants. You want to create equivalent groups, roughly the same age, the same mix of ethnicity, the same mix of gender, or whatever it is, right? And that will reduce the variation among the groups, variance within the groups, okay? If the people making up your groups are very different, then their scores are going to be very different. Okay, so you want to limit individual differences, okay, within the groups. And a way to do that is to make sure your groups are equivalent, okay? You can use random assignment and matching to do these things, right? That limits confounding and individual differences, but it has no effect on the variance within the groups. Sample size, you can increase the sample size. The more people you have in your experiment, the more likely it is that if there is a real difference between the treatment and control group, the more likely you are to find it. Something happens when you increase the sample size. When you increase the sample size, your variance and your standard deviation actually decrease when you increase the sample size. Let me give you an example of how that works. An example about Vegas. If you go to Vegas, okay, you are the odds are against you, okay? You're supposed to lose, okay, when you go to Vegas, whether you play cards or roulette or or you do the slot machines, it doesn't matter. On average, you're supposed to lose, okay, because the house or the casino, they give themselves an advantage. It might be a 2% advantage, 6% advantage, 8% advantage, depending on which game you're actually playing. Now, what happens is if you only play a few times, let's say if you only play 3 or 4 times, you might actually come out ahead. You might actually be winning a little bit. Like when I first went, I started playing roulette. Played for a few minutes. Before I knew it, I was up $60. I said, oh, this is easy. I'm going to make some money here. But the longer you play, the more the odds catch up with you. Keep playing, and eventually you will be down. Eventually you will lose. It's designed that way. Because the more samples, right, the greater your sample, the more times you participate, or the more participants you have, the greater the chance that these statistics will work out in the favor of the house, because they give themselves a small advantage. And that small advantage works out in the end. With a bigger sample size, if there's supposed to be a difference, you're more likely to find it with more participants. Just like there's supposed to be a difference, right? The house is supposed to win. The casino is supposed to win. It's designed that way. They give themselves an advantage. And there's certain little things that they do to the games to make sure they have that advantage. Like when you play roulette, there's a couple of squares there that if it lands there, you lose and the casino wins, right? That's to give themselves that little advantage. There's a few little spots, extra spots for them to make sure it's not 50-50. And the more you play, the more likely it is that that difference will occur, that difference will be found. If there's a real difference between those in aggression, between those that consume alcohol and those that did not, if there's a real difference, if you have a lot of people participate, you're more likely to find that difference if there's more people than, let's say, if there's only a few participants in your group. That's what happens with an increase in sample size. And remember, between subject designs, you already need a large sample size because you have different participants in different groups. So you need to increase the number of participants in each group. There's other threats to internal validity between subject designs. Between subject designs also have another problem. It's called differential attrition. Participant dropout rate from one group to another. Large differences between groups creates problems. So here's the thing, you have different, let me explain that. You have different groups, okay? And when you have different people in these different groups, there are some participants who can't get through the experiment, especially if you have an experiment that involves drugs, like I was doing, right, testing the effect of alcohol and aggression. You get some participants and you run them through the experiment and they're fine, they get through it. There are others, you run them through the experiment and they start having problems, you know, that they consume the alcohol and then they get nauseous or something like that. And then they drop out of the experiment. They don't complete the experiment. There's things like that that can happen, okay? And if you have more dropouts in one group than another, that creates groups that are different. Now, let me give you an example. You're more likely to have that problem with alcohol when you have, you know, Asian participants in your experiment. Now, I don't mean to be picking on Asian people here, but Asian participants, Asian people have I forget if they have a certain gene or if they're lacking a certain gene, but a lot of Asian people don't tolerate alcohol very well. It's a genetic thing. There's more of them that when they consume alcohol, they can get kind of nauseous, can get red in the face, and basically, they get, they get sick, when they consume alcohol. I'm not saying all of them, but some of them, right? And that genetic difference exists more in Asian people than in other groups. Okay, so let's say if you get more dropouts in one group than another, you can end up with different number of participants in your groups. You can end up with different types of people in each group, and that's going to be a problem. If your groups differ, then that increases the variation in the scores, and that's going to make it harder for you to find a significant result. Other threats to the internal validity. So other things that that make it harder for you to say that there's a significant result, that let's say alcohol is really causing aggression, that A caused B, right? Other problems is communication between the groups. Okay, groups can communicate. You have different participants in the treatment group, in the control group, in the placebo group, but you know what? Word gets around, and then they start talking to each other, and then that messes up your experiment. So one way that can happen is through diffusion, where the treatment spreads from one group to another. Let me explain how that can happen. Okay, if you're testing the effect of a certain drug, let's say, and this drug turns out to be this drug is potentially beneficial, or maybe is beneficial. It sometimes happens that, let's say, the people who are participating, who have a certain, let's say you're testing the effect of a drug, let's say, that might be a cure for cancer, let's say. And some people are in the treatment group, right? They're getting the real drug. And some people are in the placebo group. They're not getting the real drug. They're getting some fake one. And some people are in the control group that are getting no drug at all. And you're testing to see if this drug works. Participants are gonna as they're taking the drug, they're gonna figure out if it's working or not. And if they figure out that it's working, what sometimes happens is that those people that are in the treatment group that are getting the real drug, they know other people who also have cancer, or who also, let's say, are in the experiment. And then they may start sharing their medication. They really do things like this. They help each other out. And in that way, your treatment is actually spreading from the treatment group to the control group, which is bad, because then you're not going to be able to spot the difference. That does happen, believe it or not. When you're working on something medical, or you're trying to test the effect of some drug, and it turns out that a certain drug works. Okay. There's also compensatory equalization, where a subject demands treatment received by the other group. It could also be that your control group finds out that, hey, they have no drug, and they've learned that the drug is working. Or your placebo finds out that they have the one that doesn't work, because they know if it's working or not. And they find out that for other people it is working. They might start demanding that they get the real drug. They want to be compensated for that. They want the real drug, for instance. And if that happens, if you have to give them the real drug, then you don't see the difference between the groups. There's also compensatory rivalry, where the control group can change their normal behavior, work extra hard, let's say, to get better, because they know they're not getting the thing that's supposed to help them. Okay, they're not getting the drug that's supposed to make them feel better. So because of that, maybe they try to eat healthier, maybe they try to exercise, they try to do something so they can be healthy as well. And let me give you a better example. Let's say if you're testing the effect of exercise on weight loss. Okay. No, not weight loss, not exercise. Let's say you're testing the effect of a certain drug on weight loss. Okay. And your treatment group, they get the real drug, and they're starting to lose weight. And your control group, right? Your control group, and let's say, and your placebo group, they find out that they're not getting anything, or that they're getting something that doesn't work, right? And they're not really losing weight. Because they find out, right, that they get something that doesn't work, they might work extra hard. Maybe they, like I said before, maybe they eat healthier, or maybe they start exercising more to make up for the fact that they're not losing weight, because remember, the treatment group, they're losing weight because they're using a drug that actually helps them lose weight. That's compensatory rivalry, where the control group works extra hard, basically to compensate for the fact that they're not doing as well. It could also happen with when you're testing different teaching methods at school. Let's say one group of kids is getting the more advanced teaching method and they're doing better, and then the control group is getting the outdated, not so good teaching method, and they're not doing as well. Maybe they find out that they're not doing as well, and because of that, they study harder. They try harder to catch up to the other group. There's also the opposite, resentful demoralization, where participants in the control group become less productive and less motivated. So this could be like your participants, let's say, are getting, the treatment group is getting a drug that helps them lose weight, and the control group, they're not getting the drug that helps them lose weight. And they learn that, well, they're not losing weight, they're not getting any better, and because of that, they feel demoralized. In other words, they feel like giving up. So they don't try as much, or maybe they do things that are gonna make them even worse. Maybe you say, well, I'm not gonna lose any weight, so what the heck? I'm just gonna eat all the junk food I can, and they become demoralized. They give up, or they do things that are counterproductive. Let me give you another example of that that's probably better. Teaching methods, right? You have two teaching methods. Not teaching methods, actually. Let's say you have two groups of kids. You have your group that's advanced. Let's say your gifted kids, right? That are supposed to have a higher IQ. And then you have your average kids, right? That have the average IQ. And you test them. Let's say you test them, maybe they get the SAT test or some achievement test or something like that. And you know what happens? The kids that are in the average group, they learn eventually. They know that they are the average group. They know they're not in that gifted group. They know that group is doing better. And you know what happens to them? They become less motivated. They become demoralized. They say things like, well, we know we're the dumb ones, so why should we even try, right? Screw this, that kind of stuff. And they give up. They don't try many times. It happens a lot. Especially in schools. It doesn't so much happen with the normal kids so much, but it often happens with the kids that are special ed, where the special ed kids, eventually they get old enough and they realize they're special ed. It's like, and they find out, and they learn that they're different, and they feel demoralized, and they think, and they feel that, oh yeah, we're supposed to be the dumb ones. Yeah, we know, and stuff like that. And because of it, they don't try. And then they do even worse. That's resentful demoralization. If you're doing an experiment that's testing teaching methods, or where you're testing, let's say, a group with a higher IQ than in an average group and stuff like that, people feel demoralized when they find out, that they're in the, disadvantaged group. It happens a lot. And it really hurts people's chances in the real world when this happens, by the way. You have the poor kids, the people of color and stuff like that are disadvantaged, and they know they're disadvantaged. They know it's harder, and a lot of them give up because they know that it's harder and that they're not supposed to do as well according to the research, right? Because the people who are more disadvantaged, who are more advantaged, do better, and a lot of people give up. I've seen it, growing up in my own schools. I've seen my own friends when they're taking these achievement tests. And it gives me a sign like, yeah, I just guess, screw it, man. I don't give a damn. Why that attitude? Because he knows the test is going to show that he's not doing that well, right? So he doesn't even try, and then it looks even worse. That kind of stuff happens. That is where we'll stop, you guys. We'll talk about applications of between subject design. Eventually get to within subjects design next time. So let me stop recording.